Hi all, welcome to POWERFLIK. Today we are going to see the overview of basic electrical technology. In basic electrical technology, we are having five major chapters. One is basic principles of energy, electricity, resistive circuits, work, power, energy, heat, etc., conversion techniques, and network theorems. These five are detailedly given here. 1, 2, 3, 4, 5. In this, today we are going to learn about electric current, which is the first topic of basic electrical technology. Electric current. Before going to learn about electric current, we should learn about a very basic block of current, that is charge. Charge is an electrical property of the atomic particles. Atomic particles means proton, electron, neutron. These are the atomic particles. Every matter, whatever it is made up of these three atomic particles: proton, electron, neutron. Proton will have positive charge. The magnitude of it is 1.602 into 10 power minus 19. If you see here, we are writing C. C means coulombs. This is the unit to represent the charge. So proton is having 1.602 into 10 power minus 19 coulombs of charge. Similarly, electron is having minus 1.602 into 10 power minus 19 coulombs. If you observe, both the magnitudes are same, but the signs are different. Proton is having positive sign, electron is having negative sign. Understood? So usually positive charge will be referred as proton and negative charge is referred as electron. And we also talked about the third particle, which is neutron. It is of no charge. Only proton and electrons are having charges. Okay. Now we got a detailed understanding of charge. But how charge will be reflected as a current? Basically, the flow of charge represents the current. If a charge is moving, say this is charge, if it is moving, okay, this charge, the flow of charge is called as current. But charge means we are already having two charges, positive charge, negative charge, that is proton and electron. Which charge should be considered? Usually both will be considered, but in electric circuits, we mainly focus on the flow of electrons. So typically we consider the electron flow in the circuit as current. So the electron flow, how much electron flow is happening, will give you the magnitude of the current. How the direction of the current is determined? Direction of the current will be quite opposite to the electron flow. Okay, this is a new point. This is an important point also. So for the better understanding, I'll give you one example. Consider this as a conductor. This is a conductor. Now I am connecting negative of the battery. This is the symbol of the battery. Okay. The short leg will be negative of the battery and the tall leg will be the positive. So I am connecting like this. Okay. Now internally we'll have electrons. Electrons will be flowing from negative to positive. This is electrons. So the electrons will be coming in this direction. So this is the direction of electrons. So as per this statement, the current should be opposite to the electron flow. So the current will be in this direction. This is the current. So if I draw it here, this will be the current direction and this will be the electron's direction. Understood? Now we observed that the charge and current are very closely related, and I have shown you the theoretical link between the charge and current. But in order to solve the problems, we require mathematical link also. For that, we will be deriving a relation between the charge and current. Consider this is the conductor, like I already shown you this conductor in the previous slide. So similarly it is connected to positive and here it is connected to negative. Now the electrons are flowing from negative to positive as shown in the previous slide. For example, if I consider a cross section here, very thin slice of the conductor, if I consider that this is the cross section of the conductor. Okay, these electrons which are here must cross this cross section. So the number of electrons, so many number of electrons will cross this cross section. So the charge, how much charge is crossing will be represented by Q. If Q number of charges pass it through the cross section in t seconds, then it is called current. So I is nothing but the flow of charge, right? So the flow of charge in the sense change of something with respect to time. So here we are having change of charge with respect to time. This is a very direct equation of current and charge. Usually how we mention it, I, current I is nothing but change in charge dq by change in time. This is I. This is a differential form of I. If you have a equation, if you have a q with respect to time, then we have to differentiate it with respect to time to get I. Understood? In the same way, when you are having a differential equation, you can easily convert into integral. So this dt I am sending there. So I into dt is equals to dq, and integrating on both sides, I will integrate on both sides taking the I into dt. So this will be q and I am having integral of dt. This is another form of current with respect to charge. So we are having three forms of equation which tells us the relation between current and charge. Current is nothing but rate of change of charge. That's it. So simply we can write current is equals to rate of change of charge, or in normal terms we can write as flow of charge is nothing but current. Got it? Now if current, usually current will have so many different forms. Okay, if you see through the oscilloscope, you will have so many different forms. In that I have considered two waveforms. This is I, y-axis is I, x-axis is t. Y-axis is I, x-axis is t. This is the horizon. Now if the current waveform is constant throughout the time, this is constant throughout the time, then it is called DC current. How I am telling it is constant? Say I will divide this as 1, 2, 3, 4, 5, 6. I divided the time axis into 6 seconds. Say it is seconds. Now at 1 second, the current here is 10 amperes, say. say 10 amperes. After 5 seconds also, the current is 10 amperes only, which shows that it is constant all over the time. Therefore, it is called DC current. Got it? Now, if you observe here, 0, 1, 2, 3, 4, 5, 6, 7. Say here 6 also, consider 6 also, it is 10 amps only. But here at 1, say it is 5 amps, at 3 it will be minus 5 amps. But here for us at 3 also it is 10 amperes. So the value of the current will be changing with respect to time. It is variable with respect to time. This will be constant. A DC current will be constant all the time. So AC current will be variable with time. DC current equation can be written as I is equals to, what is the magnitude? 10 amps. Simple. This is the DC current equation. Here, this one is the DC current equation. But here, we will write I equals to 5 sine omega t. This is just a reference, like how we'll write, not exact. See, you can see the sine component with a variable t. T is nothing but time. So the equation of the current will be the function of time. That is AC current. This is DC current. Got it? So to summarize what all we learned, we are having one practice problem after this summary. Just a very small problem. To summarize what all we learned, first we saw what is charge. What are the types of charges? Correct? What is current? How current and charge are related? Q and I are related. What are the types of currents? We also saw the direction of the current. How to determine the direction of the current. So it's a very brief explanation of the current, and let us see the practice problem. This problem is taken from William Haight engineering circuit analysis. Okay. According to this problem, there is a wire. Sorry. There is a wire. This is a wire. And we'll read here. In the wire, electrons are moving left to right. This is left and this is right. Electrons are moving from left to right. So in this wire, this is wire, right? Electrons are moving like this. This is E minus. So without seeing the figure, we can easily say that if electrons are that side, the positive current will be this side. This is positive. In the same direction, if you want, then you have to represent I as negative. Now, which current is in this direction? I1. Which current is in this direction? I2. So with this, we can easily say I1 is equals to negative, I2 is equals to positive. That is clear. But what is the magnitude of the current? Here it is given 1 milliamp. So I1 is equals to minus 1 milliamp. I2 is equals to plus 1 milliamp. See here. Is it clear? I1 is equals to minus 1 milliamp. I2 is equals to plus 1 milliamp. Thank you for watching. All the best.